Hey guys, so today we're going to continue with Essential 8B, which is looking at similar triangles, and again, using those similar triangles to find a missing side. Okay, so last thing that we talked about last time we met, we were looking at two triangles, but sometimes you'll notice that they are overlapping, right? But what we can do is we can actually break them apart and now take a look at both similar triangles individually, right? It's going to help us compare them, which side corresponds to which side, making our lives a little bit easier when we're trying to find that missing side. So that's what we want to focus on today. But let's start here. Example number one. It's asking, are these figures similar, right? So number one, are they actually similar? Why or why not? If they are similar, we have to make sure that we write a similarity statement. So how do we prove whether two triangles are similar? We have to write a proportionality statement. We basically have to compare our sides, right? Create those fractions, create those ratios, and if we get the same fractions, those same ratios, something like 1/2 equals 1/2 equals 1/2, then we know we do have similar figures. So let's go through and compare. All right, so let's go through and compare using a similarity statement here. Or sorry, not a similarity statement, a proportionality statement. So let me take a look at side DE. Okay, that side right there, that's corresponding to AB. All right, so those are the top kind of left sides of these triangles. So what I'm going to do is I'm going to create a ratio here. I'm going to write a fraction. I'm going to say 15 over 5. So let me write 15 over 5. And I'm going to continue to compare that, okay, compare that ratio with the rest of the other side. So let's take a look from E down here to F. That's 6. I'm going to compare that to B to C, which is 4. So let's go ahead and write a ratio that represents that. Well, that's a 6:4 ratio here. And then again, we're going to set that equal to our third side. Again, this is how we prove whether two figures are similar. Let me go ahead and finally here from D all the way to F, that was 18. From A all the way over here to C, that's 6. That's going to be 18 over 6. So our job right now is to go through and simplify these ratios, simplify these fractions. And again, if we get the same thing equal to the same thing equal to the same thing, we know that we are good. Take a look at the first fraction here. 15 divided by 5. I can actually divide that nicely. That actually works out. I don't have to worry about simplifying a fraction here. 15 divided by 5 is just going to give me 3. Is equal to, but take a look. I can already start seeing that this is not going to be similar. 6 over 4. This fraction here, I can simplify, but I can only simplify top and bottom by 2. And if I do that, 6 divided by 2 is 3. 4 divided by 2 is 2. So far, take a look. I have 3 equals 3 over 2. That is a false statement. That is not true. Even if I simplify the last one here, what is 18 divided by 6? That one actually also divides very nicely. 18 divided by 6 gives us 3. All right, so I do have 3 and 3, which was great, but that middle fraction, 6 over 4, that's not true. It's not the same as the other. So we're going to say no. Nope. Okay, these are not similar. Okay, not similar triangles. Okay, our proportionality statement here is false. All right, so again, the ratio is not correct. They are not scaled. All sides are not scaled by the same factor. All right, so that is example number 1. So when that happens, do we have to write a similarity statement? No, it's impossible. These are not actual similar triangles. All right, number 2 here, example number 2, it says solve for x. Right, so we do have actually two similar triangles in here, but we have to break it apart. Let's break it apart so it should make our life a little bit easier to take a look at. So there is a smaller triangle that's sitting inside here. And then, of course, obviously, we have the much larger triangle. So what I'm going to do here is I'm going to rewrite this. I'm going to draw both of those, one smaller one, right? So let me just draw a smaller triangle. And then, of course, I'll draw the much larger one. What I'm trying to do here is I'm trying to separate them so we can go and play that matching game, figure out which side corresponds to which side corresponds to which side. So let's take a look just at the smaller one. I'll actually put small here so you guys can see it. It's a smaller highlighted triangle. And let's label everything I know. The left side over here measures 7x minus 1. And then the bottom side down here measures 15. Okay, And that's all I know for that small triangle. I ignore everything else, right? I'm only focusing on this smaller triangle that was on the inside. Well, let's take a look. Let's take a look now. That's since we're done with the small one. Let's take a look at the much larger triangle, right? The entire distance, pretty much all the way around this figure. So let's take a look at, first of all, the bottom side. Okay, the bottom side's not just going to be 15. It's not just going to be 6. I'm asking you the entire distance, right? I'm asking you the entire distance from corner to corner. So what do we have to do with that 15 and that 6? Well, you're just going to go ahead and add them. That would give you the entire length of the bottom side. 15 plus 6 is going to give you 21. So the true value of the bottom side of that triangle measures 21 units. Okay, we're going to do the same thing with the left side of this triangle. So again, from top over here all the way to the bottom, it's not just 8, it's not just 7x minus 1. We're going to go through and add those together. So what does it look like when you add those two things together? Well, let me maybe write them side by side. Let me take 7x minus 1, right? And let me add the 8 next to that. Well, all I can really do is combine those constants. Negative 1 and positive 8. When I combine my like terms there, that's going to give me positive 7. All right, and of course I bring down the 7x. So that left side, when I add these two values together, I end up with 7x plus 7. That's the entire distance from the top to the bottom of that left side. So let me label that 7x plus 7. All right, so now that we have that, let me erase a couple of things here. Right? All I went through and did was, again, I broke apart my picture so that I'm focused with the two similar triangles, right? It doesn't get too overwhelming trying to combine in your head. You now actually have two pictures to look at instead of one. Well, let's go through and write a proportion. Let's write a proportion, and let's play the matching game. Play the matching game. So I know here that the left side, 7x minus 1, is matching up with the right-hand side, the left side of this bigger triangle. So those are matching. So I'm going to write 7x minus 1 over 7x plus 7. Those are the corresponding sides. And this is equal to, and again, we're going to play that matching game again, but with the bottom. I'm going to say 15. Okay, that's corresponding to the bottom side of the bigger one, which is 21. So I'm going to write 15 over 21. Make sure that you are consistent. If you use the small one over the bigger one, make sure you use the small one over the bigger one again. All right, great. This just becomes a Algebra 1 problem where we have to go through and cross multiply. Be careful here, though, when we are cross multiplying. Let me find a different color here. When I cross multiply diagonally this way, I'll actually go ahead and show my work. You're multiplying here 15 times 7x plus 7. So let me write it out. I'm not going to multiply in my head. I want to show you guys the work here. It's 15 times 7x plus 7. So we're actually going to have to multiply both of those things. That's why I'm putting it in parentheses. It's like you're applying distributive property. And it's equal to, when we multiply diagonally this way, take a look, it's going to be 21 times both of those terms over there, which is 7x minus 1. So be careful. If you can do this step in your head, great, you're really using distributive property. Make sure that you're multiplying that 15 times both of those terms, and also same thing with the 21. Let's go through and actually multiply. I'm going to need a calculator here, just for efficiency. Feel free to use it. 15 times 7x, well, 15 times 7, that gives me 105x. 15 times 7 again, well, that's just going to be 105, is equal to, let me distribute the 21. 21 times 7, that gives me 147x. And then 21 times negative 1, that's negative 21. All right, let's continue to solve this multi-step equation. Draw a line down the middle. Oh, and I forgot my x actually up above. It was 147, and I forgot to write that x. Right, 21 times 7. Let me show you guys that one more time. 21 times 7 was 147x. 21 times negative 1 was negative 21. All right, at this point, you have, again, a multi-step equation. What I'm going to do is I'm going to subtract 105 from both sides. 105x minus 105x. So what is that going to give us? That gives me 42. So these cancel out. I get 105 is equal to 42x minus 21. All right, great. If I go ahead now and add 21 to both sides, what do we get? We end up with 105 plus 21. That's going to give me 126 is equal to 42x. The 21's canceled out. The last thing we're going to do here is go ahead and divide both sides by 42. So 126 divided by 42, I don't know if that divides nicely. It actually does. It's going to give me 3. 3 is equal to x. That is our final answer. All right, example number 3 here. One more time, I have to go through and I have to solve for x. I have to go through here and solve for x. So let's play a matching game, right? Let's go through and play this matching game. What sides correspond to which sides? They are similar triangles, right? This is telling me that, hey, you have 2 similar triangles. So let's use this similarity statement, right? The statement right here to help us play that matching game. Well, from S to Q, from S to Q, the last and the first letter, who's that going to match up with? It's going to match up with the last letter here, L to Q. So these are the corresponding sides. 3x plus 12 matches 24. So let me go ahead and write that first fraction. And it's up to you the way that you want to write it. Just make sure, again, that you are consistent. I'm going to write it as 3x plus 12 over 24. I'm using the bottom triangle over the one on top. Again, if you wanted to write it the other way, you actually can, as long as you're consistent. If you wanted to write it as 24 over 3x plus 12, you absolutely can. And actually, maybe I'll do it this way. That way we can see kind of the top triangle on top, bottom triangle values on the bottom. Okay, so let's continue to play this matching game. This is now equal to, well, let's take a look at this side here, from K to Q. Right, so from K to Q, using those the first 2 letters, K and Q, that's 32. Who does it match up with? Q and R. So those are the other set of corresponding sides. So again, be careful. Since I did do 24 over 3x plus 12, I got to make sure that I'm consistent. I'm going to say 32 over 72, right? So make sure to be careful that you're consistent. You're using the same triangle, same way that when you're creating your fractions. All right, let's go through and just play this cross multiplication game. This time, I'll multiply diagonally this way first. 24 times 72. Let me use a calculator for this. Where's my calculator? There we go. 24 times 72. That gives me 1,728. And this is equal to, I'm going to multiply again diagonally this way. Be careful. I'm going to multiply this one using my calculator. Remember, 32 times both of those things, 3x and 12. So what is 32 times 3x, or times 3? That gives me 96x. And don't forget to multiply 32 again times the 12. This is kind of the most popular part where students mess up. They forget to multiply both of those things on the bottom by 32. So 32 times 12 gives me positive 384. Great, it's a 2-step equation here. What I'm going to do is I'm going to go ahead and subtract 384 from both sides, minus 384. So what is that going to give me? That's going to give me 1,344 is equal to 96x, because those, of course, canceled out. The last thing we're going to do here, is go ahead and divide. Let me find a different color. Divide by 96. Divide by 96. Let's see if that actually divides nicely. It does. 1,344 divided by 96 gives us 14, and 14 is equal to x. That is our final answer. All right. Example number 4. Same idea here. I want to go through and I want to solve for x. So let's use that similarity statement to help us set up our proportion. All right. So I'll start off with from M to S. Let's use this side 20 here, from M to S, using the first two letters, M and S. That's going to be S and T. S and T. So again, be careful, make sure that you guys, again, are using that similarity statement to your advantage. Don't, again, just assume just because they look a certain way that those are the corresponding sides. Make sure that you guys are using that statement or any other angle symbols that you see in your actual picture. So these are the sides that are corresponding. These are the matching sides. I'll go ahead and write 20 over 5x plus 10, and this is going to equal, all right, this is going to equal, well, let's play the matching game again. Which side does LS correspond to? LS, 22 here, from the last letter and the first letter. We're going to use the last letter U and the first letter S. U, S. So 22 is corresponding. That's matching with this side over here. That's 77 units. So because I went 20 over 5x plus 10, I'm going to go and write 22 over 77. Okay, just a matter of going through and cross multiplying. If I cross multiply this way first, 20 times 77. Let me get my calculator out one more time. Whoops, I just had it open and I closed it. 20 times 77, that gives me 1,540. And this is going to equal, cross multiply again. That's 22 times 5x and 22 times 10. So what is 22 times 5, or 5x? It's 110x. Don't forget to do, again, 22 times 10. That gives us positive 220. All right, it's a two-step equation. All right, whoops, sorry, I made a little mistake here. So we do get 220. Now I do have to subtract that from both sides. 220 minus 220. Also do it to the left, minus 220. So what is 1,540 minus 220? That gives me 1,320 is equal to 110x. Those, of course, canceled out. One more thing we're going to do here, we're going to divide both sides by 110. Hopefully that divides nicely this time around. I made a little typo earlier. So it actually does. 1,320 divided by 110 gives us 12, and that is what's equal to x. That is our final answer. Solve for x. We are